Right, so let's look a little bit more in depth at this idea of the nuclear reactor, how it works, and this idea of a nuclear meltdown, which is an easy phrase to say. This is what it actually means. You've got the uranium fuel rods in the core of the reactor. These are crucially kept cool by pushing water through that whole reactor vessel. If the water was to do this, drop below the fuel rods, this is where the problem starts. The temperature of the core rises. Control rods are then inserted to shut off the nuclear reaction, but the heat's going to keep building because of radioactive decay. If those rods are not then resubmerged into the coolant, if they stay exposed as they are, the core will start to melt through the reactor vessel, and after that, well, the molten nuclear fuel hits the steel containment floor. From then it would take less than 24 hours for the core to melt through its containment structure. That is what we call, scientists I should say, call a total meltdown, and when that happens, radioactive materials could escape with devastating effects. Imad Khadouri with me here in the studio, a nuclear scientist, to work through some of all of this. I'm conscious of being alarmist because what we've just shown there is the total meltdown scenario, which it doesn't appear to be in Japan. I'm still interested to know, however, what is the scenario of that? If any nuclear reactor got into total meltdown, what actually happens after that?
When the total meltdown happens, the 100 tons of uranium, which is the core of the reactor, would then become molten at 4,000 degrees centigrade. And they would then melt the containment, which is the primary containment. It's a stainless steel, 15-20 centimeters thick at the bottom. They will melt through that. Then they will melt through the concrete, which is holding up this shell, this reactor. And that will take, as you said, perhaps 24 hours. But then that molten uranium at these high temperatures, because of the radioactive decay heat being generated all the time, very high heat, it will bore through the earth, through the ground, through the crust of the earth. And you cannot stop it.
Goodness me.
There's 100 tons of molten uranium at 3,000 degrees centigrade, burning its way through the ground. Now, if it happens that there are some underground water systems or cavities, then there'll be leakage and contamination, very serious contamination. But that molten ball will continue to burn through the crust until it reaches the very hot layers of earth in the middle of the earth and gets mixed up with that. There's no way to stop it.
No, and presumably no way of preparing or preventing that. If this is the worst case scenario, then you can't, if it's going to get to that level, you can't stop it happening, you can't stop it.
No, there's not been, fortunately, any total meltdown. The worst that we have known is in 3 Mile Island, 1979. 1/3 of the uranium core was melted. That caused the fracture of the primary containment, and there was release of the other case of Chernobyl. There was an accident. There was an they couldn't control the reaction, and that actually blew up. The reactor blew up. So it isn't that as if that core melted on itself and became this molten lava.
Now, the difference here between, well, this is Chernobyl actually we're looking at, the difference between an event like this and what's happening in Japan right now, correct me if I'm wrong, is that it's not in Japan an acute explosion, an acute event. It's actually been a bit more controlled than that, so we're not looking at these sorts of scenarios.
It's very much more controlled, and that's what's giving us confidence that it will not get much worse than this. Yes, as soon as the earthquake occurred, the 3 reactors, there were, by the way, 6 of them there in that site. 3 were in service, and 3 were running. Now they immediately shut down, and the diesel generators started pumping in the cooling water, but less than an hour later the tsunami hit, and they disabled the backup generators, and that's where the big problem occurred. The water cooling stopped flowing to the reactors, and then because of the very high heat, hydrogen develops inside the container building, the building which houses this core of the reactor. And that's what happened in Unit 1. It exploded.
Explosion, right, okay.
And then Unit 3 is probably going to explode also. But the container itself, the 20 centimeters thick steel container, which has uranium, 100 tons of it inside, is still intact. And I cannot see a way of that breaking or releasing a lot of energy. Because they've taken desperate measures of pumping in even seawater with all its salinity, which means that these two plants will not function anymore because of corrosion and problems like that.
But it's
a desperate effort.
But it stopped it.
It will stop. It will stop. It will not be as worst case scenario as Chernobyl.
Imad Khadouri, thank you for your thoughts there, your perspective as well. Very interesting. Thank you.
You're more than welcome.